Yeah, my name is Pablo Zavattieri. I'm the Sherry and Lynda Engelhardt Professor of Civil and Construction Engineering at Purdue University. So we are looking at nature. In particular, we are looking at mosquito antennas to understand the vibration, the dynamics, the mechanics of these structures, and trying to replicate that for applications like tsunamis, earthquakes, natural disasters, how to detect cues, how to detect frequencies that actually are telling us that we are in danger. Yeah, we're studying mosquito antennas because they are fascinating structures in nature that actually are showing us how mosquitoes are capable of actually finding very, very tiny sounds and noises in very noisy environments. This is kind of similar to trying to listen to somebody whispering at a soccer football game, right? So it's very, very difficult from the engineering point of view, imagining nature when you are actually in the middle of the jungle, trying to actually listen to very, very tiny sounds. Mosquitoes are capable of actually finding that, and those are cues to actually find food, or for example, for some male mosquitoes to find the female mosquitoes. So going back to the engineering applications, we are also thinking about detecting infestations when you actually are very, very tiny bugs eating food, right? So those can be potential applications for building this specialized sensor, right? So these antennas are telling us a lot of things about how vibrations actually work in very noisy environments, and basically when we are trying to actually detect very, very, very faint sounds, right? So we are thinking about that maybe we don't need two antennas or one antenna like the mosquito. Maybe we need to build skins full of these antennas. And we are thinking about using additive manufacturing and advanced manufacturing processes to actually create this type of sensors that can eventually be used for structural monitoring, natural disasters, earthquake, etc. So we are actually looking at a three-dimensional model, a scale-up model of a mosquito head. So we are actually looking at the head right here, and the two antennas that actually have a lot of hairs here. These are the ones that will detect the sound, will detect the pressure waves coming in and out. And basically this actually works like a sailboat, trying to capture those waves. And the antenna, this is the main antenna shaft, will vibrate according to these hairs, and it will bring all that information to the Johnston organ right here that actually brings all that information to the neurological path that will interpret that data. So all this is structural mechanics and mechanics of materials as we know it, right? This is the engineering side of the mosquito.